Welcome to Star Technology 5G. In today's video I will show you how to measure temperature in Fahrenheit. Let's start the video. Please subscribe to the Star Technology 5G and click on the bell icon. How to convert Celsius into Fahrenheit? Fahrenheit is a way of measuring temperature that is commonly used in the United States. To make a Celsius temperature into a Fahrenheit, multiply the Celsius temperature by 1.8 and add 32. Fahrenheit equals 1.8 multiply by Celsius temperature and add 32. Example, convert 30 degrees Celsius into Fahrenheit. Fahrenheit equals 1.8 multiply by 30 degrees Celsius and 32. Answer is 86 degrees Fahrenheit. Project: How to measure temperature in Fahrenheit. In this project, we will connect 8 bits analog to digital converter IC ADC0804 with PIC16F877 microcontroller. And we are using an analog temperature sensor LM35. We will interface LCD with port C and ADC interface with port D of the PIC16F877 microcontroller. First, we will read the temperature in Celsius. After that we will convert it into Fahrenheit and display it on the LCD. Here is the circuit diagram we are using in our project. It is PIC16F877 microcontroller. Pin number 1 is master reset. If we press the switch it will reset the microcontroller. Port B interfaced with LCD data pins. Pin RC0 interfaced with EN pin of LCD. Pin RC1 interfaced with RW pin of LCD. Pin RC2 interfaced with RS pin of LCD. Pin VSS connect with ground. Pin VDD connect with positive 5 volt. Contrast pin VEE connect with variable. And the value of the variable is 5 kilo ohm. ADC0804 is an analog to digital converter. All data pins DB0 to DB7 interfaced with port D of the microcontroller. Pin RC5 interfaced with CS pin of ADC. Pin RC6 interfaced with RD pin of ADC. Pin RC7 interfaced with INTR pin of ADC. Clock reset pin interfaced with 10K resistor. Clock in pin interfaced with 150 PF capacitor. VREF interfaced with variable resistor and its value is 1K. It is LM35 temperature sensor. Positive pin connected with positive 5 volts. Negative pin connected with ground. Output of the LM35 connected with analog input pin of ADC0804. Pin numbers 13 and 14 interfaced with an 8 MHz crystal. And 22 PF capacitors connected with the crystal. Pin number 11 and 32 connected with positive 5 volts. Pin number 12 and 31 connected with ground volt. Let's draw this circuit in Proteus. Circuit is ready. Now we will write it code in Micro C for PIC. Here is the window where we can write the code. I already wrote the code, otherwise video gets very long. I will copy the code. And I will paste it here. Now I will define the code. Hashtag define LCD port B. Define port B as LCD. Hashtag define ADC port D. Define port D as ADC. S-bit EN at port C B0. Define enable pin at port C pin RC0. S-bit RW at port C B1. Define read write pin at port C pin RC1. S-bit RS at port C B2. Define RS pin at port C pin RC2. S-bit RD ADC at port C B5. Define ADC RD pin at port C pin RC5. S-bit WR ADC at port C B6. Define ADC WR pin at port C pin RC6. S-bit INTR at port C B7. Define ADC INTR pin at port C pin RC7. Void MS delay. Unsigned char time. Define delay function with variable name time. Unsigned char. Y, Z. Define variable name y and z. 4. Y equals 0. Y less than time. And increment y. For loop for delay. 4. Z equals 0. Z less than 254. And increment z. For loop for delay. Void delay. Unsigned char time. Define delay function with variable name time. Unsigned char. M. Define variable name m. 4. M equals 0. M less than time. And increment m. For loop for delay. Void LCD-CMD. Unsigned char x. Define LCD-CMD function with variable named x. LCD equals x. Send data to LCD. RS equals 0. RS pin equal to logic 0. RW equals 0. RW pin equal to logic 0. EN equals 1. EN pin equal to logic 1. MS delay 5. Call delay function. EN equals 0. EN pin equal to logic 0. Void LCD data. Unsigned char x. Define LCD data function with variable named x. LCD equals x. Send data to LCD. RS equals 1. RS pin equal to logic 1. RW equals 0. RW pin equal to logic 0. EN equals 1. EN pin equal to logic 1. MS delay 5. Call delay function. EN equals 0. EN pin equal to logic 0. Void LCD string unsigned char *str. String send function. While *str. Stay in this loop while data not finish. LCD data. *str++. Send data to LCD one by one. Void LCD ini void. LCD initialized function. MS delay 250. Call delay. We used maximum delay because LCD needs some time to power on. LCD CMD 0x38. Call LCD command function and give hex value 38. Set LCD in 8-bit mode, 2-line mode and 5x10 dots. LCD CMD 0x0C. Call LCD command function and give hex value 0C. Set LCD display on. LCD CMD 0x01. Call LCD command function and give hex value 01. That is command for clear LCD. Void convert display. Signed int value. This function convert binary code decimal to ASCII code and display on LCD. Signed int, Celsius Fahrenheit D1 D2 D3 D4 L1 L2 L3 L4 L5 and L6. Define variables. Celsius equals value. Copy value into Celsius. L1 equals Celsius divide by 100. And take reminder with 10. This line find the 100 digit and copy that digit into L1. Hold first digit. L2 equals Celsius divide by 10. And take reminder with 10. This line find the 10 digit and copy that digit into L2. Hold second digit. L3 equals Celsius and take reminder with 10. This line find the digit and copy that digit into L3. Hold third digit. L1 equals L1 plus 0x30. Add 0x30 into L1 and copy result into L1. Convert data into ASCII code. L2 equals L2 plus 0x30. Add 0x30 into L2 and copy result into L2. Convert data into ASCII code. L3 equals L3 plus 0x30. Add 0x30 into L3 and copy result into L3. Convert data into ASCII code. LCD CMD 0xC1. Call LCD command function and move cursor line 2 at position number 2. LCD data L1. Call LCD data function and print L1 data. LCD data L2. Call LCD data function and print L2 data. LCD data L3. Call LCD data function and print L3 data. LCD data 0xDF. Call LCD data function and print degree sign. 0xDF is code of degree sign. LCD data C. Call LCD data function and print C. Fahrenheit equals value. Copy value into Fahrenheit. Fahrenheit equals Fahrenheit multiply by 1.8 and add 32. Convert into Fahrenheit and save result into Fahrenheit. D1 equals Fahrenheit divide by 100. This line find the 100 digit and copy that digit into D1. Hold first digit. D2 equals Fahrenheit minus 100 multiply by D1. D3 equals D2 divide by 10. This line find the 10 digit and copy that digit into D3. Hold second digit. D4 equals D2 minus D3 multiply by 10. This line find the digit and copy that digit into D4. Hold third digit. L4 equals D1 plus 0x30. Add 0x30 into D1 and copy result into L4. Convert data into ASCII code. L5 equals D2 plus 0x30. Add 0x30 into D2 and copy result into L5. Convert data into ASCII code. L6 equals D4 plus 0x30. Add 0x30 into D4 and copy result into L6. Convert data into ASCII code. LCD CMD0xC9. Call LCD command function and move cursor line 2 at position number 7. LCD data L4. Call LCD data function and print L4 data. LCD data L5. Call LCD data function and print L5 data. LCD data L6. Call LCD data function and print L6 data. LCD data 0xDF. Call LCD data function and print degree sign. 0xDF is code of degree sign. LCD data F. Call LCD data function and print F. Signed int temp. Define variable. Void. Main. Main function. TRISB equals 0x00. Set port B as output port. TRISC equals 0x00. Set port C as output port. TRISD equals 0xFF. Set port D as input port. LCD INI. Call LCD initialization. MS delay 200. Call MS delay. INTR equals 1. Set INTR pin at logic high. RDADC equals 1. Set RDADC pin at logic high. WRADC equals 1. Set WRADC pin at logic high. LCD string temperature. Call LCD string and write temperature on LCD. While 1. Repeat forever loop. WRADC equals 0. Send logic low to WRADC pin. MS delay 10. Call MS delay. WRADC equals 1. Send logic high to WRADC pin. While INTR equals 1. Wait for end of conversion. RDADC equals 0. Send logic low to RDADC pin. For reading data from ADC0804 we need to send logic low to RD pin. Temp equals ADC. Copy ADC data into temp. RDADC equals 1. Send logic high to RDADC pin. It will stop reading data from ADC0804. Convert display temp. Call convert display function, convert ADC data into temperature and display on LCD. MS delay 254. Delay between next cycles. Now we will create the hex file. Just click on the build icon. Finished successfully. File is created. Now we will load hex file into the microcontroller. Double click on the microcontroller. Select the hex file. OK. And click on the run simulation. Now LCD show temperature on it. Adjust temperature setting from vref variable resistor. If we will increase LM35 temperature, then temperature is increase on LCD. If you have any problem with the code, let me know in comments. Thanks for watching. Please subscribe to the Star Technology 5G. And keep watching Star Technology 5G.